Hello dear student, welcome to all. We already discussed what is parallelogram law, triangle law and polygon law. Suppose we have two vector and their which consist both different direction and magnitude. At that time we get the resultant vector, and that resultant vector r vector equal to a vector plus b vector, and because this is resultant vector which possess direction as well as magnitude, and how can we find direction? Magnitude. So in this case magnitude of resultant vector that is a square plus b square plus 2ab cos theta. What is theta? Theta is angle between two vector, means a vector and b vector. Suppose this is vector a and here another one vector b, and angle between them is theta. And if we use parallelogram law, law of vector addition, then this diagonal give the resultant vector r vector, and whose magnitude is this much. Clear? And how can we find direction? This angle is theta, angle between two vector, but this angle is alpha, which show the direction of resultant from vector a. So here we already discussed that is tan alpha equal to b sin theta divided by a plus b cos theta, where alpha give the direction of resultant vector. This is for two vector. If more than three vector acting at a point, at that time suppose three vector represent both magnitude and direction, at that time we can find the resultant vector r vector equal to a vector plus b vector plus c vector, and this law is known as Polygon law of vector addition. Clear? And we already discussed equilibrium condition, means suppose there is three vector a, another one vector b and another one vector who is c vector, and they form a closed loop, closed triangle. Here these three vectors are in same order, that means according to equilibrium condition a vector plus b vector plus 0 vector which give c vector which give a 0 resultant, and this condition is known as, that is equilibrium condition. Equilibrium condition. The resultant vector here is 0 vector for any closed loop. Clear? Now we will start the important factor of physics or important factor of vector, that is known as resolution of vector. Clear? So now let us start resolution of vector. So what is the meaning of resolution of vector? Actually it is the splitting of vector. गोटे vector को हमें split करिबा. How can we divide a vector into different component? Suppose I am taking one example. Suppose there is a car like this. One car is here. Suppose I have a toy and this is car. It is easy to break the car, but it is difficult to combine or difficult to form a new car. गोटे कार को भांगिबा पई केते इजी लागे. छोट बेले तुम खेलना खेलथिबो तो गोटे कार आनले, बाबा गोटे कार आन देले 2 घंटा पर देखियो कार राव खंड विखंडित हो जाइथिबो. दैट मीन्स इट इज इजी टू ब्रेक द कार. कार को भांगिबा पई बहुत इजी, बट इट इज डिफिकल्ट टू मेक अगेन, difficult to regain its original shape. तापर ओरिजिनल शेप को कार को जोड़िया पई बहुत डिफिकल्ट. And here splitting of vector आमे एडी बाहर कर देले, one wheel पळेला पाखे, one steering ए पाखे, one wheel ए पाखे. These are the component of car. These are known as component. आमे एडी wheel नवा, टायर नवा, हैला steering नवा. All these are component of a car. Clear? Similarly, we already discussed what is r. R vector equal to a vector plus b vector. If two vector possess both magnitude and direction, तो दीटा vector रो magnitude अच्छी और direction अच्छी, हमें already discuss कर सकते हैं ना. R vector equal to a vector plus b vector, where a and b vector are known as component of resultant vector, means here r vector. Clear? बट आम डिफिकल्ट काम कर सारे. व्हाट इज डिफिकल्ट काम ना दीटा कंपोनेंट को नहीं कि आम रिजल्टेंट बाहर कर सारे. मीन्स व्हील, स्टीयरिंग, टायर, जहाँ भी सब इंस्ट्रूमेंट अच्छी, इंस्ट्रूमेंट को नहीं कि आम ऑलरेडी कार तैयारी कर सारे. डिफिकल्ट काम सरला. आम ए इजी काम देखा माने कार को केमती भांगिबा हाउ टू ब्रेक ए कार how to resolve a vector into its rectangular component or into its different type of component, that is known as resolution of vector or splitting of vector. Clear? बर्तमान में कार को केमिति भांगिबा से विषय पढ़िबा. That means if the resultant vector, now we have to split this vector, a vector को भांगिया दरकार, and we will obtain a relation that is component A and another one component B. These are known as component of vector R. Clear? So it is known as resolution of vector. So what is the meaning of resolution of vector means? It is the splitting माने different separate कर देबा भांगिबा. It is the splitting of a vector into its component and it is known as rectangular component. Rectangular component, that is known as splitting of vector or resolution of vector. Clear? Okay, you already know what is 2 dimension and what is 3 dimension case. 2 dimension case kono or 3 dimension case kono, 2D 3D तो सब already जानिजो. That means there is x axis and y axis. You can take suppose x axis here and y axis here, and suppose I have a vector here, this vector which represent r vector. ये r vector अछि and this r vector which make an angle theta with suppose this is one axis x axis, but we can shift the vector from one position to another position without change its magnitude and direction. बिना magnitude direction change करिकी आमे गुटे vector को गुटे point रो आ गुटे point को shift कर परिबा. So in this case we have to shift this vector r here. This represent the vector that is known as r vector. Clear? This r vector which make an angle theta with this axis, this is known as x axis. So in this case we have to find the resolution of vector or splitting of vector. Now first we have to draw a perpendicular here. This is perpendicular and this angle is here 90 degree. Clear? If this angle 90, this angle theta, then this distance, suppose this distance I am taking here, you can take, suppose I am taking here, this is a vector, suppose this is a vector and here this is a vector. Clear? And this distance I am taking here, suppose this distance ax. So how can we find this distance? Look at this triangle angle 90 angle theta is here, but this is the magnitude of a vector which represent hypotenuse, and this is height h, this is p and this is base b equal to here ax. We have to find the value of ax, so we have to use cos theta is here. So cos theta is your base angle, cos theta equal to base upon hypotenuse, and base is here ax divided by hypotenuse a. So ax equal to, what is ax here? So ax can be write ax equal to a cos theta. So this value we got here, that is a cos theta. Clear? Again, now you have to draw a perpendicular this point to along this line or along y axis. This is another one perpendicular here. This is perpendicular and this angle also 90. If this angle theta, because total angle 90, clear, then this angle will be 90 minus theta. How much? 90 minus theta. And now this is base, this triangle means here. So this angle which 90 minus theta, and this is the magnitude and its magnitude a, and here if this angle 90 minus theta, then this is base. So base and here this is perpendicular. So here you can calculate this base. So cos theta is here 90 minus theta equal to b by h, and b is here this b. Suppose I am writing here this distance b, and this distance I am taking here ay because y direction, and here b which is equal to ay. I am writing here ay divided by h, and this is h distance which is equal, hypotenuse which is equal to a. So ay comes out to be here ay equal to a cos 90 minus theta, cos 90 minus theta, which gives the first quadrant. But first quadrant all the trigonometric functions are positive, so you can write cos 90 minus theta which is equal to a sin theta ay. Clear? Here ax. Now if you draw a clear diagram here, then here x axis and this is y axis here. Clear? And this is the vector a. This is perpendicular line which meet at this point, and this total distance along x axis can be right here ax, which give the value is here a cos theta, and this angle is theta, means a vector which make an angle theta with positive x axis. So if you want to draw a perpendicular here, then this angle also 90, and this total distance along y axis which give ay equal to a sin theta. Clear? So here ax and ay are the rectangular component of a vector. Ax and ay are the rectangular component of a vector along ax which direction? Along x axis, and ay along y axis. This ay and ax is known as rectangular component. एबे जो a vector थिला, a vector split हो गला. Now a vector splitted up into two component along x axis and y axis. That component is known as rectangular component. A vector एबे divide की a cos theta, a sin theta. A sin theta को a sin theta and a cos theta is known as component of vector a कहा जाए. Why it is called rectangular component? Because here if we draw another one diagram, then which show ax and how much? Ax equal to a cos theta, and here ay equal to a sin theta, and angle between the two component ax and ay is 90 degree. So it is represent rectangular. याको component कहा जाए क्या रो? A vector रो. Why it is called rectangular? Because the angle between two vector is 90 degree. तो जान जो rectangular रो angle कितने थे? Always 90. So it is known as rectangular component. Clear? ताले a vector पे divide ही गला दीटा component रे a cos theta, a sin theta. Clear? केमिति easily तो मन रखि परिबो. How to you can easily remember this term? देखो ये एंगल थीटा जो साइड एंगल लागी थिबो से साइडटा सबले केते आसीबो a cos थीटा, जो साइड लागी नथिबो एंगल a sin थीटा. Clear? So these are all about rectangular component of a vector which split into two component, and angle between their component is always 90 degree. Clear? So that it is known as rectangular component. Clear? Okay. This rectangular component can be represented in two-dimensional figure or unit vector, because this is result a vector and this angle theta, and this component here ax which equal to a cos theta, and here this component ay a sin theta. This is resultant vector. But we already know how to define a unit vector along x, y, and this is z axis, there is origin 0, 0, 0, and along x axis we have to take I cap, along y axis j cap, and along x axis k cap. Clear? If ax, ay are two rectangular components along x and y axis, can we represent this rectangular component in the form of vector? Yes. So how can we represent this term? देखा आम ए पॉइंट को पहुँचे अच्छी देन वी हैव टू आर दिस डायरेक्शन फास्ट आम एडी जीवा देन वी हैव टू आर दिस रिलेशन अकॉर्डिंग टू ट्रायंगल लॉ ऑफ वेक्टर एडिशन एंड दिस इज रिजल्टेंट वेक्टर व्हिच गिव द ऑपोजिट डायरेक्शन मीन्स दिस सपोज ए वेक्टर एंड हियर वाई वेक्टर एंड दिस इज सॉरी ए वेक्टर बी वेक्टर व्हिच गिव द रिजल्टेंट वेक्टर. क्लियर? सो इन दिस केस वी हैव टू रिप्रेजेंट ax. A scalar vector. This is scalar quantity, but along x-axis. If you want to make it vector, then we have to use a unit vector here. जदि हमें ax को vector करिया पय चाहिबा, then we have to use here ax I cap means ये vector रहे गला. कोड डायरेक्शन रे ना x-axis रे. केते magnitude? That is ax. Similarly, vector can be shift. This vector is here a sin theta. Now you can shift this vector here. अरे भाई ये vector कितना है? Now this vector comes to be a sin theta which is equal to ay. But this is along y axis. This is along x axis and this is along y axis. So we can write this direction that is ayj cap. Clear? So there is vector. This vector represent ax I cap, this vector represent ay j cap, and this is the resultant vector that is a vector. And what is a vector? A vector, suppose this vector plus this vector which give the resultant vector, and it is always opposite order to that of a and b. So in this case you can write here that is a vector equal to this vector plus this vector, and here ax I cap, ayj cap is the vector form. Clear? So these are scalar component of a vector along x axis and along y axis. एबे ये vector along x axis, ये vector along y axis दीटा को आड़ला पर कितना आसी? So like r vector equal to a vector plus b vector. पहले दीटा vector आड़ कोला परे कौन आसी? third vector. Or if you resolve this vector a which into two component, a component and b component, so that's why it is known as splitting of two vector into rectangular component. Clear? Okay, so we got here a vector equal to ax I cap plus ay j cap. Now we have to use here value. So a vector equal to can be write rectangular component for x equal to a cos theta I cap plus ay a sin theta j cap. This is the vector a in terms of rectangular component a cos theta x axis and a sin theta y axis. So we have two relation as we have two relation ax equal to a cos theta and ay is here ay equal to a sin theta. This is suppose equation number 1, this is equation number 2. Now squaring equation 1 and 2, squaring equation 1 and 2 and adding them, then we got the resultant vector. Both side को square करके add कर दवा ताले first टाइम square करले कितना होला? So here we get x square plus square करके add कर दियो left hand side को left hand side and right hand side to right hand side. So here ax square plus ay square equal to a square cos square theta plus here a square sin square theta. But here a square is common quantity, so you can take one common here a square, then the remaining part cos square theta plus sin square theta, and the value of cos square theta plus sin square theta, which is equal to 1. So we got the value is here a square. So ax square, ay square, and again there is square. If we take a is here, then under root ax square plus ay square. This is known as magnitude because this is vector, a vector here, and its magnitude. So this is the magnitude of a vector in two dimension. That is two dimension x axis and y axis. Clear? A type of vector कौन कर परिवा? We can resolve a vector into rectangular component. Clear? Okay. So you can find also unit vector. How can we find unit vector? If we want to write unit vector here, because we have a vector, what unit vector representation, that is a vector divided by magnitude of a vector. So a vector equal to ax I cap, ay j cap divided by magnitude of a. This is magnitude of a vector, and here ax square plus ay square under root. This shows the direction of unit vector, and its magnitude always 1. If you want to write magnitude always 1. If we multiply this vector with scalar, then it gives the direction of a given vector. Clear? So these are all about rectangular component of a vector. Suppose if we take another one example regarding rectangular component of vector. So suppose question may ask a force 4 Newton acting a force 4 Newton acting on a particle 30 degree north of east. Find its rectangular component. Rectangular component along x or along east and north. So how can you solve it? Now draw first the direction of east, west, north, south. Then now represent the question here. East, west, north and south. Suppose there is a particle, a force 4 Newton acting on a particle 30 degree. Force 4 Newton acting on a particle north of east. North of east means this direction. North of east means this angle is 30 degree. North of east. Clear? And here the force magnitude, that is 4 Newton. Now we have to resolve into rectangular component. This is rectangular component is here. So this direction we can write. This is f. Suppose here I am writing f1, and f1 how much? If this vector is suppose f vector this direction, f cos theta. F cos theta. So I am writing here f cos theta, and along this direction f sin theta. F sin theta. जो एंगल लगी थी वो ताकू cos theta लिखिबा, जो एंगल लगी न था ताकू sin theta लिखिबा. Then this value f is here 4 into cos theta and cos 30 degree. That is 4 into cos 30. How much? Its value cos 30, which is equal to root 3 by 2, and 2 to 4. So 2 root 3 Newton along this. You can take, suppose this is x axis, and here you can take, suppose this is y axis. Clear? And this vector you can write here, f1 vector can be write, that is 2 root 3 x axis, and the representation of x axis, that is I cap. So we get that is F vector. But this is only magnitude. This is only component of force along x-axis, or you can say magnitude. Clear? Okay. Now this is, you can write here F2. This is F2 vector. F2. So F2 equal to F sin theta. F sin theta, and F is your 4 sin 30 degree, and 4 into sin 30 half 2, then 2 Newton, and this is F2. This is magnitude. But along y-axis, so you can write F2 vector equal to 2j cap. Clear? We already discussed this is a resultant vector, then its component F1 and component F2, or this component केते लिख परिबे, a component को, that is this component can be write F1 I cap, and this component can be shift here, and this component can be write here F2 j cap. F1 I cap, F2 j cap, which give resultant. So F vector is here, that is F1 I cap plus F2 j cap equal to F1 how much? F1 is here 2 root 3 I cap plus here 2 j cap. This is the vector form. Clear? Okay. ताले यार magnitude केता हबा? If I want to find magnitude of this vector, 4 या 7 करने दरकार. Why? Because its magnitude is your 4 Newton. Now we have a formula a square plus b square under root. So I am writing here 2 root 3 square plus b square under root. How much? So 2 to the 4 into 3 plus here 2 to the 4. Clear? Which is 16, which is equal to 4 Newton. So we get this relation here. Clear? So these are example regarding resolution of a vector into its rectangular components. Clear? Okay. So you can take another one example regarding resolution of vector. Suppose I am taking another one example is here. X axis, y, and here negative x axis, or you can say x dash, and here y dash. This is origin. Clear? And there is a vector. Suppose I am writing here this is vector f, and which make an angle, this angle theta. Find rectangular component of this vector along x axis and y axis. So how can we find rectangular component? Now first you have to draw a perpendicular here, this angle 90, and जो side angle लगी थी वो सेपटा में कितना लिखिबा f cos theta. So this side f cos theta, and resolve into two rectangular component. Here got a component along x axis and another one component along y axis, and this component is known as f sin theta. Clear? The vector format रे लिखिबा. So f sin f cos theta, but which direction along x axis? So I cap. F cos theta I cap. Similarly downward direction, upward direction by j cap, downward by minus j. So you can write here that is minus j cap. Clear? That means f cos theta I cap plus how much? F sin theta minus j cap, which give the resultant vector, and is here f vector. So how much f vector? So f vector can be write f cos theta I cap plus this vector. How much here? It is f sin theta, but here minus j, downward direction. So resultant vector can be write f cos theta I cap minus f sin theta, that is j cap. This is the resultant vector. Clear? So by using this concept we can solve different type of numerical regarding this concept. Suppose if we take another one example, this is a 90 degree inclined plane, you can say here. Suppose this angle theta, and there is a body whose mass m and force acting on it, that is known as gravitational force mg. Find its rectangular component. A rectangular component केमिति बाहर करिया दरकार. So in this case we have to use this angle is theta and this point. So these two lines are parallel to each other and there is the intersection point. So this angle theta means this angle you can say we have to draw rectangular component. Man ये है vector rectangular component केमी दिया rectangular component along this direction and the angle between components should be 90 degree. ए दीटा component भितर angle केते हेबा दरकार 90 degree हेबा दरकार. You can take origin at each point, each and every point. तुम को point रो origin नहीं परिवो. So मो a point originally मन करो ये नली मो ए पाके suppose x axis and this is y axis. एम axis है वाला y axis and this axis according to my convenience. Clear? And this is vector is here. This vector is mg. Okay. If this angle theta and this is the line intersection you can say, then this angle will be theta. This angle theta means theta. Two line and this angle theta, theta. So this angle theta and this angle 90 minus theta because total angle is here 90. So this angle 90 minus total 90, this angle theta 90 minus theta and this angle is also theta. Or simply you can say if you draw a line here, then this angle 90, this angle 90 minus theta, so this angle theta. Clear? Now come to this relation. So this angle we got theta here. Now we have to draw a rectangular component like this. Y, X, and this is here mg, but this angle is theta here. Now draw rectangular component this direction. So this side is known as जो angle लगी थी वो cos theta. So mg you can write here mg cos theta. जो side टा लगी थी वो mg cos theta. जो side लगी न थी वो means a side टा कितने बार दरकार? That is mg sin theta. This mg sin theta and mg cos theta is known as rectangular component of this mg. Clear? So these are all about resolution of a vector and how to find rectangular component of this vector by using different type of situation or different type of condition. Clear? Okay. So by using this concept you can solve different numerous of problem regarding this resolution of vector, and this concept is very important while when you discuss about dynamics or free body diagram. Clear? So you have to remember this concept and how to solve different type of numericals. Clear? Next we will start position vector. Position vector. So what is position vector? Suppose there is a particle P at point P and this particle x comma y point. Now we have to specify this position of the particle and first we have to choose a origin. Clear? Origin है important. भाई मु 10 किलोमीटर डिस्टेंस मु पचारि तुम क्वेश्चन तुम दौड़ दौड़ के आसिलो भाई केते डिस्टेंस आसिलो 10 किलोमीटर. अरे कोड 10 किलोमीटर स्टार्टिंग पॉइंट गोटे थे ना नहीं बुझिला ना. तुम ब्रह्मपुर 10 किलोमीटर आसिलो ना भुवनेश्वर 10 किलोमीटर आसिलो बुझिउछ द ना कटक 10 किलोमीटर आसिलो डिपेंड करे इनिशियल पोजीशन and that initial position is known as origin and this point is known as origin. Origin means where all the distances are measured from that point. जो point रो हमें सब distance को measurement करिबा से point को कौन कहा जाए origin. So in this case first we have to choose a origin and here two dimensional figure this origin 0, 0. A point रो measurement टा start हबो. Okay, now let's start particle which situated at point P x comma y means x रो किछि distance रे अछि and y रो किछि distance रे अछि. So this component is known as x comma y. Now we have to find here what is position vector. First we have to choose a origin, then now draw a straight line from origin to that point and now mark a vector symbol. This is known as position vector. Suppose this origin O is here and OP vector, suppose I am writing here R vector. OP vector is known as R vector is called position vector. Clear? So first we have to choose a origin and draw a straight line from origin to that point, and that vector which represent the position of a vector. Clear? And to important significance of this vector, it gives the straight line distance from origin to that point at any instant. Any instant माने कौन सी टाइम रे भी से पोजीशन दे पारिबो और डिस्टेंस टा में मेजरमेंट कर पारिबो फ्रॉम दिस पॉइंट टू दिस पॉइंट. एंड सेकंड इंपोर्टेंट पॉइंट, दिस इज नोन एज सिग्निफिकेंस. Significance of position vector, or you can say R vector. And second thing, it gives the direction of the particle from origin to that point. Clear? Origin to that point. ये origin रो कोड डायरेक्शन अछि ये डायरेक्शन इंडिकेट करि पारे. So this is known as position vector. Suppose this angle is here theta, and theta is represent angle of position vector along from x axis. X axis रो केते angle रे position vector अछि. Clear? Okay, this is known as position vector. Now you can draw its rectangular component form or unit vector form, and this angle is 90 degree, and you already know this is resultant vector R vector, and जो angle लगी थी वो से साइड हम कितना लिखिबा, this distance is known as R cos theta, and this distance along y axis known as R sin theta. R cos theta and R sin theta are two rectangular component of this position vector. But ये x axis पाई, so in x axis suppose this vector I am writing here x equal to R cos theta, small x, this is capital X is here, small x equal to R cos theta and small y equal to R sin theta. Now you can write this position vector in rectangular vector form is here, and this is position vector R vector and this angle theta, and here x, but this x which is along x axis, so you can write x I cap. Clear? And this vector which is along y axis, and we can write y j cap, this angle theta. But vector can be shifted from one place to another place without change its direction and magnitude. This is yj cap. Now this vector shift here, so this is direction of yj cap, xi cap plus yj cap, which is equal to R vector. So R vector can be write here, that is xi cap plus yj cap unit vector form. So this is the position vector in unit vector form. Can we find its magnitude of this position vector? Okay, so R vector equal to what is x? X here R cos theta. R cos theta I cap plus y R sin theta j cap. Clear? This is known as position vector. So remember one thing, suppose this is vector A and its magnitude ax I cap plus ay j cap, then its magnitude how much? Its magnitude ax square plus ay square under root. We already discussed about this relation. So you can find the magnitude of position vector, and here this much, or you can say here this x and y, x I cap like ax I cap x square. So here we can write ax square plus y square is magnitude, or you can find also from this relation from here, or from this relation you can calculate the magnitude of r vector equal to r cos theta square, and here that is r square cos square theta, clear, plus r square sin square theta under root, and r are common here, so r equal to here cos square theta plus sin square theta, this is square, and this value is 1, we get r. So magnitude of r which is equal to r. But this is important relation, how to find the position of vector x square plus y square under root. Okay, position vector in unity vector form. So what is unity vector? So representation of unity vector of position vector can be right here, that is r cap equal to r vector divided by magnitude of r vector, and r vector is here, this is r vector, so you can write xi cap y j cap divided by r magnitude of r vector, and magnitude of r vector is here, so you can write here a square plus y square under root. This is known as magnitude of this is the unity vector, clear. So this is the format how to write unity vector in two-dimensional form, clear. Okay, and you can take another one example. Suppose if you want to change the origin, then what will be the position vector? जब तुम origin को change कर दब ताले position vector किसी फरक पड़िबो ना नहीं? There is any difference if you displace the origin. Suppose this is origin and this is position vector r vector, this point p x comma y. Now I am changing this origin x and this comma y. मैं origin एवं change कर दिली. Now origin is here x and y, and this particle situated at this point. Now this is the distance, because position vector always measure from the chosen origin. आम जो origin choose करथिबा से origin रो distance रे measurement करिया कोन कहा जाए position vector. बर्तमान एटी position vector कोन हैला distance बढ़ी गला. सो जदि आम origin change कर दबा ताले position vector भी कोन होई जिवो से position vector भी change होई जिवो. क्लियर. एगला टू डायमेंशन केस. So what will be position vector in three-dimensional case? So three-dimensional case is important. So you have to remember it carefully, how to find position vector in three-dimensional form. Clear? Okay. Now I am drawing here three-dimensional figure. X axis, and this axis is y here, and z axis. This is origin 0 0 0, and in three-dimensional case all the three axes are mutually perpendicular to each other. तीनटा को axis perpendicular भाग रचंदी. What is the angle between them? Suppose this is x axis, x axis, y axis, and z is here. This is three-dimensional figure, x, y, and z. But z को more two-dimensional figure देखि परिबिनी. So I am drawing here. This is z axis, and angle between x axis and y axis is 90, and y and z also 90, and z and x also 90 degree. Clear? A three-dimensional figure x, y, z mango एटी particle अछि. There is a particle in space, not in the board. A board रे नहीं mango एटी particle अछि. So how can we represent this particle? How can we represent the position of this particle? A particle situated in space. So particle space रे अछि मान three-dimensional figure रे अछि. ताको हम केमिति specify करिया? Suppose there is a particle p, and which x, y, z, three-dimension case rachi. So in this case we have to draw a triangle here. Sorry, this is the position vector. and this position vector, suppose I am writing here r vector. Clear? Okay, this r vector you can directly write, or how can we represent this vector? Because this is three-dimensional case, x-axis, y-axis and z-axis, and here the position vector r which match and some angle, this is position vector in this case. So a angle thibo theta, or epa kichi angle thai pare, or epa ki kichi angle thai pare. So how can we represent this vector in three-dimensional case? So in this case, there is a plane, this is known as plane, and this plane is known as xz plane. xz plane rachi. Clear? So first draw a perpendicular here, and clear? आम resultant vector बाहर करिया. केमती बाहर करिया? First we have to come along z axis, then first z axis I am writing here z k cap, then this is x axis, then here this axis is x axis, so you can write here x axis x I cap. According to triangle law, these two vectors are same order and which give the resultant vector and which represent third, and this is opposite order. Clear? And this vector is now z k cap plus this vector is here x I cap. Clear? Okay, look at this triangle again. So another one triangle is here, this and this triangle, these are same order, these two vectors are same order and which give the resultant direction. Clear? So I am taking this direction means along y axis, so you can write here yj cap. This vector plus this vector which give the resultant vector, and this resultant vector is opposite order, so you can write this r vector can be write this vector which x I cap, x I cap, z k cap, and here z k cap plus, and along y axis and y j cap. If you rearrange this term, then you can write x I cap, y j cap plus z k cap. This is the resultant vector in three-dimensional case. Clear? Or you can find its magnitude of this resultant vector. How much? X square plus y square plus z square under root, and its unit vector, that is r vector at magnitude, which is equal to x I cap plus y j cap plus z k cap divided by its magnitude. So x square plus y square plus z square under root. This is the unit vector, and this is the position vector magnitude, and this is position vector in three-dimensional case. Clear? So first along this direction and this which give resultant, then this direction and this, then we get a final resultant which represent the position vector in three-dimensional figure. Clear? Okay. This is all about position vector and how to calculate position vector. First we have to choose origin. Now draw a straight line which starting from origin to that point, and that vector which represent position vector of the particle. Clear? So by using this concept you can calculate magnitude and its direction of position vector. Now let's start. Displacement vector. Displacement vector. So what is displacement? Actually displacement is the shortest distance or shortest path between 2 points, or you can say initial and final point. Suppose in two-dimensional case, here x axis and this point is your y axis. Clear? And there is 2 point A and this point suppose x1 comma y1, and if there is particle, first we have to choose origin here. This point is origin. Now we have to draw a straight line which starting from origin to that point, which give the representation of particle when at point A. And this position vector you can write, suppose this is r1 vector. Clear? And now particle which move this direction and reach at another one point B, this direction, and its position x2, y2. And now we have to draw position vector each here to represent magnitude and direction of that particle. So this is position vector, and you can write r2 vector. So in this case, what is the shortest path between 2 points? Particle A point to B point को displace, sorry, move कला. Then what is the shortest path? Now you have to draw a straight line which passing through these 2 points. The straight line draw करो. जो straight line दा data point को pass करी जाऊ थो. And now you have to make a arrowhead which always initial to final point, because it start moving from point A to point B. So this point A is known as initial point, and B point is here, that is final point. Clear? And this direction which show the displacement vector, and you can write displacement vector. Suppose I am writing here D vector. Clear? Okay. If this is D vector, then by using triangle law, of vector addition, suppose this point OAB is a triangle. So in this triangle, R1 vector and D vector are along same order. So same order means we can add this relation by using triangle law. R1 position vector plus D displacement vector, which give the resultant, or which give the third side of the triangle, and closing side you can say, which show the opposite order. R1 and D same order, and here R2 vector which represent resultant, that is opposite order is here R2. But here we have to find displacement vector is D. So D is known as, that is displacement vector. So displacement vector is here, that is R2 vector minus R1 vector. So what is the definition of displacement vector means? It is the shortest distance between 2 points and directed from initial to final point. Clear? And that vector is known as displacement vector. So here displacement vector D vector equal to, this is displacement vector. Displacement vector D vector equal to R2 minus R1. Okay. So what is R1 vector? From this we already discussed what is R1. R1 equal to x1 I cap plus, that is y1 j cap. Clear? And what is R2? R2 vector equal to here x2 y2, so x2 I cap plus, that is y2 j cap. Now you can represent this displacement vector in displacement vector in unit vector form. So you can write here, that is displacement vector D vector equal to R2 vector minus R1 vector. So R2 vector minus R1 vector, and R2 vector is here x2 I cap plus y2 j cap minus here x1 I cap plus y1 j cap. Now I1 and common is your I1, so you can write x2 minus x1 I cap plus y2 minus y1 j cap y2 minus y1 j cap. This is the displacement vector in terms of unit vector form. Clear? Okay. So if we want to find its magnitude, then how can we find magnitude of this vector? So magnitude of displacement vector, that is magnitude of d, which is equal to x square plus y square, and we have to use a square root here or under root, that is x square plus y square, because here unit vector I and here unit vector is j cap. So you can write x2 minus x1 whole square plus y2 minus y1 whole square. Clear? So this is unit magnitude, and you can write this unit vector. So this vector divided by magnitude of d vector can be write, this vector is here x2 minus x1 I cap plus y2 minus y1 j cap divided by here x2 minus x1 whole square plus y2 minus y1 whole square under root. Clear? Okay. This is the magnitude and unity vector, and this is the displacement vector in terms of position vector, unity vector form. Unit vector form. Clear? Okay. So now you have to remember one important thing is here. If we change origin, now I am changing origin here, then this is the position vector at this point, and this is also the position vector at this point, but this distance remain constant. So here displacement vector which independent of origin, but position vector which depends on origin. बुझेला? जब मैं origin change कर दबा, displacement vector constant, but position vector changes. So these are two important factors. Clear? And this displacement vector you can write in three-dimensional figure. Clear? So displacement vector, how can we write three-dimensional figure? So in three-dimensional figure, suppose there is another one point. Suppose I am writing here. Suppose this point is Z1, and here point B, that is x2, y2, and z2. X-axis and y-axis x, y, and another one axis z-axis here. Okay, if you draw a clear diagram. So displacement vector in three-dimensional figure. X-axis, y, and z. These axes are mutually perpendicular to each other. So there is a point. Suppose this point A, and its position you can write x1, y1, and z1. And this particle which displaces from one point to another. Suppose this point is B is here, and this point you can write x2, y2, z2, and its position vector. So this point A, you can write r1 vector, and here r1 vector in three-dimensional case we already discussed. So you can write x1 I cap plus y1 j cap plus z1 k cap. Clear? So similarly, position vector at this point, that is r2 in three-dimensional case, you can write r2 vector equal to x2 I cap y2 j cap plus, that is z2 k cap. Clear? Okay. Now find displacement vector. This is known as displacement vector, and this vector is d. So d vector is displacement vector equal to r1 vector plus d, which is equal to r2. So you can write r1 vector plus d vector equal to r2 vector. R2 vector is here. but we have to find displacement d equal to r2 minus r1. Now use all the value r2 minus r1. So r2 is here x1 r2 x2 y2 z2. So I am writing x2 I cap plus y2 z cap plus z2 k cap minus r1 x1 I cap x1 I cap y1 j cap and z1 k cap. Clear? Now I1 I cap common is here, so you can write here x2 minus x1 I cap plus j cap common here y2 minus y1 j cap plus then k cap you can take common z2 minus z1. So z2 minus z1, that is k cap, and this is known as displacement vector in unit vector form. And you can find its magnitude of displacement vector, that is a square plus b square plus c square under root. So you can write here a square means x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is the magnitude of displacement vector, and you can write unit vector, that is d cap equal to d vector by magnitude of d vector. This is known as unit vector, and here d vector and this is magnitude vector, then you will get the unit vector of displacement vector. Clear? So these are all about 2-dimensional and 3-dimensional case of position vector and displacement vector. Clear? Okay. Now let's start direction cosine. Clear? This is important, you have to remember, that is direction cosine. Okay, so what is direction cosine? By direction cosine what? How can we find its magnitude direction of the direction cosine? So actually direction cosine is basically an angle. So a co-angle. Now you have to imagine in 3-dimensional figure. Suppose I am drawing here a vector. Suppose this is x-axis and another one axis here y-axis, and here this axis is z-axis. Clear? And this is origin 0, 0, 0. So in 3-dimensional case, this is 3-dimension, x-axis, y and z. Suppose there is a point or there is a particle in 3-dimensional figure. So this point means this is 3-dimensional figure here. And this point, suppose I am writing here A. And first, how can we find position vector? First we have to choose origin. Now draw a straight line which give the position vector. And suppose this vector is a vector in 3-dimension case, x, y and z. Now keep in mind, what is the angle made by this vector A along x-axis, this vector A along y-axis and z-axis? That angle in the form of cos is known as direction cosine. That means this is x-axis, y-axis and this is z-axis. So if you want to write definition first, so direction cosine are the angle which are the cosine angle, you can write. Direction cosine are the cosine angle which make a given vector. Suppose here given vector A vector which make a given vector with x-axis, y-axis and z-axis. अब जो given vector A vector नेले, what is the angle of cosine form of the given vector with x-axis, y-axis and z-axis? ए वेक्टर रो एंगल ला x एक्सिस रे y एक्सिस रे आ z एक्सिस रे कैसे इन cos फॉर्मेट रे सपोज दिस इज x एक्सिस y and z and this is vector this direction clear. So if vector this direction is here, this vector a vector, and this is x axis, so what is the angle between x axis and this vector? X axis and this vector a and this vector, this angle is known as suppose alpha, writing here alpha. And what is angle made by this vector a with y axis and this angle, suppose this angle is known as, I am writing here, this angle is beta, and again this angle is made a vector with z axis and this angle is gamma. Clear? Here you can say L, M, N. L, M are represent the direction cosine. So first we have to take only component along x axis, component along y axis and component along z axis, because in three dimensional case x, y and z you have to remember it. Clear? So टिके बुझिया ପାଇଁ चेष्टा करो x axis, y axis, z axis हम गोटे वेक्टर चूज कले थ्री डायमेंशन रे तले ए वेक्टर जो अछि ए वेक्टर x axis केते एंगल अल्फा. क्लियर? जदि ये अल्फा एंगल क्रिएट कला तले एक कंपोनेंट ता केते यू कैन राइट अलोंग x axis, सो ax इक्वल टू a cos थीटा, जो एंगल लगी था से एंगल लिखा जाए थीटा, सो वी कैन राइट हियर a cos थीटा, दिस इज कंपोनेंट, सॉरी cos अल्फा इज हियर, and again angle केते अछि बीटा, so its component along y axis you can write a cos beta. Similarly along z axis you can write a cos gamma. Clear? So we can write a vector. We already discussed how to represent a 3D vector or three dimensional case. First we have to come this direction and suppose this vector, you have to remember this vector. So first we have to draw here like this. Clear? So first we have to come along z axis, then along suppose x, y, z axis, then x axis, this is the resultant, and this is how much x plus z, then this direction plus this vector, and we get a resultant vector. And here this vector is x plus z and this is y, so x plus y plus z, which is resultant vector r vector. We already discussed in three dimensional case. So this r vector can be write here, sorry, a vector can be write in three dimensional case, means this direction ax and its vector quantity ax, this is magnitude. If we multiply with a scalar, sorry, if we multiply with a direction, then it behaves as a vector, and direction is here, that is I cap, ax I cap plus this is x axis, so you can write ax I cap. Clear? Then this is z axis, how can you write, that is z k cap, means here az, this is az, and here this is ay, so you can write ay j cap plus az k cap. I don't write directly तो मैं लिख पारिबो ax I cap, ay j cap, az k cap, but एटी ax केते, ax is here a cos alpha, a cos alpha I cap, and here a sin, sorry, a cos beta j cap plus a cos gamma k cap. Clear? And ax is here a cos alpha, and what is cos alpha? Cos alpha equal to, you can write L, and which equal to ax divided by a, magnitude of a vector. एक को है direction cosine, इला direction cosine, so the direction cosine in terms of L. Similarly ay equal to a cos beta, and what is cos beta? Cos beta equal to ay divided by a ro magnitude or a. Clear? Similarly az equal to a cos gamma, and cos gamma is here equal how much? That is az divided by magnitude of a or simply a vector. Clear? So cos alpha, cos beta, here cos alpha equal to L, cos beta which is equal to M, and cos gamma which is equal to N, L, M, N. So cos alpha, cos beta, cos gamma, or simply you can say L, M, N are direction cosine of vector A along x-axis, y-axis and z-axis. cos alpha, cos beta, cos gamma को direction cosine कहा जाए, और simply you can write L, M, N, and L what is ax by a, what is here M, ay by a. A means a magnitude, this is a vector. Clear? Okay, so how can we find magnitude of this vector? A vector is here. So if you want to find magnitude of this vector, then we can write here, this is a vector is here. So magnitude of a vector equal to, we can write here ax square plus ay square plus az square under root. So what is a square? A square is here, you can write a square cos square alpha plus a square cos square beta plus here a square cos square gamma. Clear? Now solve this relation a square, so you can take a square common, and here cos square alpha plus cos square beta plus cos square gamma under root. This is common quantity, and square you can take here out square root, so you can write a cos square alpha plus cos square beta plus cos square gamma. Clear? Or under root is here, and this is a vector, you can write here a. So a both side cancel, so you can write this term here, that is cos square alpha plus cos square beta plus cos square gamma root over equal to 1. So cos square alpha plus cos square beta plus cos square gamma equal to 1. This is another one formula of direction cosine. Clear? So cos square alpha, cos square beta plus cos square gamma equal to 1. But in trigonometry relation you already know how can we write cos square theta. So cos square theta in terms of sin square theta you can write here also. So cos square alpha or cos square theta equal to 1 minus it is sin square theta. Clear? Okay, because cos square theta plus sin square theta equal to 1. So if you use this relation here, you can write cos square alpha 1 minus sin square alpha plus cos square beta 1 minus sin square beta plus cos square gamma 1 minus sin square gamma equal to 1. Now solve this relation here. So 1 minus minus, so you can take a minus common one here. First, right? 1 1 1, so 3 minus sin square alpha plus sin square beta plus here sin square gamma equal to 1. Clear? So if you take this term right hand side, then you can write 3 minus 1 equal to sin square alpha plus sin square beta plus sin square gamma, and that is sin square alpha plus sin square beta plus here sin square gamma equal to 2. This is another one formula of direction cosine in terms of sine function, and here this is cos function. Clear? So these are all about position vector in 2 dimension, displacement vector 2 dimension, 3 dimension, and direction cosine. Clear? Thank you all.